In the last lecture, we know that we have seen the Ostwald dilution law for weak acid and weak base. Now, in this lecture, we are going to start autoionization of water H2O. We know that nature of water. Water is a weak electrolyte. Why it is weak electrolyte? Because it ionizes to very small extent. It is a bad conductor of electricity because it extent it ionizes to very small extent. We know that water is a neutral one. Why it is called neutral? Because the concentration of H plus ion and the concentration of OH minus is equal, and that has to be 10 raised to minus 7 mole per liter. Now my recent point is autoionization of water. Now what is autoionization? Autoionization means water molecule itself gets ionized. So this is autoionization of water, which means the water molecule itself gets ionized, which means one water molecule react with other water molecule, that we call it self ionization or autoionization of water. So two water molecule combine together to form H3O plus plus OH minus. Now because the water is a weak electrolyte, we have shown here a double-headed arrow or pair of arrow. Because it is water is a weak electrolyte, here we have shown double-headed arrow or a pair of arrow. Now water react with water to form H3O plus plus OH minus. Now this is called autoionization of water or ionization of water. That reaction is called autoionization of water. Now, in such case, in case of ionization of water, here we can apply Bronsted-Lowry theory. According to Bronsted-Lowry theory, what is acid, what is base? According to Bronsted-Lowry theory, acid is a proton donor, H plus donor, and base is a proton acceptor, means H plus acceptor. So here we can apply Bronsted-Lowry theory. Water converted to H3O plus by gaining H plus, and here water is converted to OH minus by losing H plus. So here this water loses H plus. It gives us H plus. That is why it is called acid. This water second molecule is called acid. According to Bronsted-Lowry theory, acid is a substance which donate H plus, and that is why water H2O is converted to OH minus. Where second molecule H2O is converted to H3O plus by gaining H plus. So this is called base. So this is called base. So here we can apply in this reaction ionization of water, we can apply Bronsted-Lowry theory. Acid is a substance which donate H plus and convert it to OH minus ion, where H2O, another H2O, it accept H plus and it converted to H3O plus. So this is H plus donor, that is why it is called acid, and this is H2 H plus acceptor, that is why it is called base according to the Bronsted-Lowry theory. Now here we are applying the equilibrium constant for the ionization of water, means law of mass action. Here we are applying law of mass action, which means for ionization of water, the equilibrium constant K, here we are introducing. So we are introducing equilibrium constant capital K. Capital K is equal to concentration of H3O plus into concentration of OH minus is to be divided by concentration of H2O into concentration of H2O, which means concentration of H2O square, bracket square, concentration of H2O, bracket square. So product side on the upper side of the division, uh, numerator part always, and reactant side always down part of the division, means denominator part. So denominator part, so K is equal to concentration of H2O plus into concentration of OH minus divided by concentration of bracket H2O square. Now we can interchange this. Here we can H2O square, we can multiply K, so we can interchange this equation. So K into H2O square, we can interchange this K into H2O bracket square is equal to concentration of H3O plus into concentration of OH minus. Now we know that the concentration of water is taken as constant. Why it is taken as constant? Because most of the water molecules are undissociated, because pure water is a weak electrolyte. So we can say that the most of the water molecules, pure water molecule, undissociated. Therefore, the water molecule, the concentration of water molecule taken as a constant one. So we can take on H2 constant is K dash. So we can take on this constant is K dash. So K into K dash is equal to concentration of H3O plus into concentration of OH minus. So here we can take it as concentration of water constant, which is denoted by K dash. So now K into K dash is equal to KW. So here K into K dash is equal to KW is equal to same here H3O plus OH minus. Now what is Kw? Kw is equal to K into K dash. So we are substituting the value of Kw instead of this K into K dash, because Kw is equal to K into K dash. Now what is Kw? Kw means ionic product of water. Kw is called ionic product of water. So Kw is defined as the product of molar concentration. Ionic product of water is equal to concentration of H3O plus into concentration of OH minus. Now how we can define Kw, ionic product of water, theoretically? So Kw means ionic product of water is defined as it is a product of concentration of hydronium ion or hydrogen ion and the concentration of hydroxyl ion at equilibrium in a given temperature, at a given temperature in a pure water. So again, Kw means ionic product of water is defined as it is a product of concentration of hydronium ion or hydrogen ion means H3O plus and concentration of hydroxyl ion means OH minus at equilibrium stage in a pure water at a given temperature. Now we know that in case of pure water, the concentration of H3O plus and concentration of OH minus remains same. So in case of pure water, the concentration of H3O plus and concentration of OH minus same, and that has to be 10 raised to minus 7 mole per liter. So we are introducing this number, the value of H3O plus and OH minus, the concentration value in this equation. So this equation becomes Kw is equal to concentration of H3O plus 1.0 into 10 raised to minus 7, 1 point bracket 1.0 into 10 raised to minus 7 mole per liter into concentration of OH minus, which will be same, that will be 1.0 into 10 raised to minus 7. So into 1.0 into 10 raised to minus 7 mole per liter at mole per liter or mole per dm cube means capital M at 298 Kelvin means at 25 degrees Celsius. So we can multiply these two. We can multiply these two. 1.0 into 10 raised to minus 7 into 1.0 into 10 raised to minus 7. So we will getting Kw is equal to 1.0 into 10 raised to minus 14. 1.0 into 10 raised to minus 40. So this is our final answer. This is your major answer. Kw is equal to 1.0 into 10 raised to minus 40 means this value is of the Kw means ionic product of water only applicable at 298 Kelvin. This value applicable only for this temperature, given temperature at 298 Kelvin. Suppose the temperature changes, then also then in that case the value of Kw changes. If we have the more temperature, then we have got the more value of kW. Means this value is for only for 298 Kelvin. Temperature changes, the value of kW changes. So value of kW at 298 Kelvin, that has to be 1.0 into 10 raised to minus 14, or we can say that the value of ionic product of water is equal to 1.0 into 10 raised to minus 14. So that was regarding the auto ionization of water. Thank you.
pH scale. My last point was auto-ionization of water. Now here I'm going to start next point, and that is a pH scale. Now who defined pH scale, or who gave the pH scale? The scientist Sorensen in 1909 gave the pH scale. He defined the value of pH and pOH. Now he defined the value of pH according to him, according to Sorensen. The pH is equal to negative logarithm to the base 10 concentration of H plus ion. Now, what is the meaning of P? P represent power and H represent hydrogen, means power of hydrogen. Another term we have POH, where P is the smaller one and OH is a capital one. Likewise, here also P is a small letter and H is a capital one. Now, pH means power of hydrogen. Here POH, another term, P means power and OH means hydroxyl ion, means power of hydroxyl ions. Here power of hydrogen and here power of hydroxyl ion. So pH is equal to, according to Sorensen, Sorensen gave the pH scale, Sorensen defined the value of pH. According to him, the pH is equal to negative logarithm to the base 10 concentration of H plus ion. And according to Sorensen, pOH is equal to, same can be applied here, negative logarithm to the base 10 concentration of OH minus ion. Now you can see over here, in both terms we use the negative sign here. We in the both term we will use the negative sign here, negative logarithm to the base 10, negative logarithm to the base 10. Why we use negative sign? Because we want the value of pH in a positive sign, means we want the value of pH and pOH in positive one, because the concentration of H plus and concentration of OH minus is very less, about 10 raised to minus 7. So minus into minus is equal to plus. So here, by applying this negative sign, concentration of H plus is very small in the negative one, 10 raised to minus 7. So negative negative, we get positive value. So at the end we get the positive value of pH and pOH. So that is why we will use here negative sign, because the concentration of H plus in the negative form, 10 raised to minus 7. Here also the concentration of OH minus in the negative sign, 10 raised to minus 7. So minus into minus, we get the value of positive one. That is why will use the negative sign in case of pH and pOH. So according to the Sorensen, who gave this scale is called as pH scale. Also this scale is called as Sorensen scale. So according to the Sorensen, the definition of pH here and definition of pOH. Now we shall see the relation between pH and pOH. So next point, the relation between P and pOH. How we will explain it? By using ionic product of water. Means by using ionic product of water, we will see the relation between pH and pOH. So let's find out the relation between pH and pOH from ionic product of water. So this is ionic product of water. Kw is equal to concentration of H2O plus into concentration of OH minus. So this ionic product of water that we have already discussed in the last point, autoionization of water. So we know the value of Kw, and the value of Kw is equal to 1.0 into 10 raised to minus 14. So we substitute here the value of Kw in place of Kw, 1.0 into 10 raised to minus 14. So the remaining part, right hand part, same here, concentration of H3O plus, concentration of H3O plus into concentration of OH minus is equal to Kw. The value of Kw, 1.0 into 10 raised to minus 14. So 1.0 into 10 raised to minus 14. Now this is the equation. We only introduce the value of Kw in place of Kw 1.0 into 10 raised to minus 40. So this equation becomes concentration of H3O plus into concentration of OH minus is equal to the value of Kw 1.0 into 10 raised to minus 14 or 10 raised to minus 14. So this is equation number 2. Now we are applying the logarithm on both sides of this equation, means equation number 2, and we can apply the logarithm on both sides of the equation. So uh, this equation becomes log to the base 10 log to the base 10 concentration of H3O plus concentration of H3O plus log to the base 10 concentration of OH minus log to the base 10 concentration of OH minus is equal to here we will apply logarithm on both sides of the equation. First left side of the equation and then to the right side. So left side log to the base 10 concentration of H3O plus log to the base 10 concentration of OH minus is equal to log to the base 10 10 raised to minus 14. So log to the base 10 10 raised to minus 14. So here we will apply the logarithm on both sides of the equation. So when you simplify this log to the base 10 10 raised to minus 14, you will getting the value of minus 14. So when you simplify this log to the base 10 10 raised to minus 14, we get the value of minus 14. So this equation becomes log to the base 10 concentration of H3O plus log to the base 10 concentration of OH minus. When you simplify this, we get the value of log to the base 10 10 raised to minus 14 is equal to minus 14. When we simplify this, we will getting minus 14. So the next step, so this is equation number 3. This is equation number 3. Now we multiply on both sides of the equation by minus 1. Here we are applying logarithm on both sides of the equation. So we get this one log to the base 10 concentration of H3O plus log to the base 10 concentration of OH minus is equal to minus 14. Now for this equation we multiply both sides of the equation by minus 1. So this equation becomes minus log to the base 10 concentration of H3O plus bracket. Here also we multiply this term by minus 1 like this. So minus log to the base 10 concentration of OH minus bracket complete. So on both sides of the equation we multiply by minus 1 is equal to minus 14 into minus 1, so 14 is equal to 14. So we get this one when we multiply minus 1 on both sides of the equation, minus logarithm to the base 10 concentration of H3O plus again we multiply next term minus 1 into logarithm to the base 10 concentration of OH minus, and here also we multiply minus 1, so minus 14 into minus 1 14. Now what is the value of this one? We have to identify these two terms, this one and this one. Minus logarithm to the base 10 concentration of H3O plus is equal to what? And another we have to find out minus logarithm to the base 10 concentration of OH minus is equal to what? And we already know that according to the Sorensen defined pH is equal to negative logarithm to the base 10 H plus. Means here we got the value of this one. negative logarithm to the base 10 constant H plus means pH. So here we got the value of this one, H plus means H3O plus, H3O plus hydronium ion, or we can say that H plus ion. So both are same. Concentration of H3O plus means concentration of H plus. Both are same. H plus or H3O plus same. H3O plus means hydronium ion and H plus means hydrogen. We can replace here also H3O by H plus, means we can use H3O plus instead of H plus, or we can use H plus instead of H3O plus. So negative logarithm to the base 10 concentration of H plus means negative logarithm to the base 10 concentration of H3O plus. So here we got the value of this one is equal to pH. And next term, negative logarithm to the base 10 concentration of OH minus means POH. So we substitute both these values in equation number 4. This is equation number 4. So we substituting both these values in this equation, and this equation becomes pH plus negative logarithm to the base 10 concentration of OH minus means POH, and negative logarithm to the base 10 concentration of H3O plus or H plus is equal to pH. So pH plus POH is equal to what? Is equal to 14. So this is your final answer, this is your major answer, or you can say that the relation between pH and pOH, and the relation that is pH plus pOH is equal to 14. This is your major answer, final answer. So this is the relation between pH and pOH, which is pH plus pOH is equal to 14. So that was regarding the autoionization of water, and then next point pH scale, and then relation between pH and pOH, which is